Good morning from Southern California. I'm Charlie Jackson. I'm the chair of the online forum on climate change technologies. I'd like to welcome you all here, and I'm looking forward to two separate groups starting today for the next 4 days and starting December 2nd for the 4 days there. We'll have a lot of interesting talks. The plan will be to post them, but it takes a longer time to post a video than you might think. So anyway, I want to thank everybody for joining us and ask you to pass the word to your friends and colleagues. Our first speaker today will be Bruno Meyer. We'll be talking about what is IEEE doing about climate change technologies. Bruno has over 38 years experience in industry in the field of energy. He joined EDF, Électricité de France, pardon my pronunciation, in 1985, where he held several senior management positions during his career. Skipping further along, since 2021, Bruno Meyer is Secretary General of GEO15, a global association of very large power grid operators. And he is president and consulting firm Consult BKM. Bruno, please start your presentation. Thank you.
Thank you very much. Thank you very much, Charlie. Thank you very much, Ravinder, for your invitation to speak to this distinguished audience. It's a great pleasure and honor, and I hope that it will fulfill some of your expectations. So I should just add to what Charlie just mentioned about my brief resume that I've also been a long-term volunteer at IEEE, and I was uh, chair of Technical Activities Board in 2022, and this will come back in my presentation. Also, this is a very long series of slides. The deck will be shared, I believe, for those who want it. I may not present them all, depending on the allocated time. I'll try to stay within well below 1 hour, and I will be presenting my slides. Hopefully, okay. I'm trying to get the next slide on. Excuse me. This is something we did not control. Uh, okay. Do you see my outline slide?
Yep.
Okay. So it's the title of this presentation is really to focus on IEEE and climate change, but I think important to give some background of what climate change is all about, why technology has an influence on climate change, even though many of the people attending this presentation are aware of that, it's still, I think, important to really reinforce all of what is going on and all that can be made. This is items 1 and 2. Item 3, I will underline the importance of IEEE in this and why IEEE wisely is engaging in climate change, and have a final slide just giving possible next steps. So this is just a slide which was updated yesterday on climate change evidence. So many of the things that you have here are pretty well known to you. Like on the top of this chart, there is a reminder of 2023 being the world's warmest year on record. So this is something very impressive. And this is also the world's warmest year on record in a following of many other very warm years. So definitely the Earth is undergoing temperature increases, and this leads to a series of extreme events which are becoming more and more frequent. Of course, extreme events have taken place throughout the history of the planet, but now they tend to be more and more frequent, more and more violent. And the last picture that I've added to this slide is the one at the bottom middle with the pile of cars. This is a picture taken in Valencia, Spain, where there's just seeing it, looking at this picture gives a sense of the violence of what's going on. The I'm going to stop here just for a second. there are plenty of things which are taking place, like in this case, in the case of Valencia, Spain, it's a weather phenomenon that the experts call the cold drop. It's related to the heating of the Mediterranean Sea. But but what technology can also do here is improve the forecasts. And there is an example of IEEE work in improving the forecast in terms of timely forecasts and more geographically focused forecasts. There is a question of wildfires. Some of you are based in California, but wildfires have been uh, taking place in Canada, in Europe, in Australia. So, I mean, many places of the world. And all these pictures are pretty impressive. There is this is the title of this first section, which is the, the costs to society that climate change is causing. So I call it the multi-trillion critical issue. Uh, People can discuss the number of trillions, but certainly this is the order of magnitude. So we talk about thousands of billions of your favorite currency, let's say US dollars or euros, and much more if you talk about yens. Uh, so the numbers are increasing by decades. We see that on the right part of this slide, we see that the numbers are going uh, not over the top. It's not an exponential growth, but it's very strong growth of the cost. This is important to underline because climate change is one issue, climate change mitigation is another. And mitigation comes with a cost. And this doesn't go doesn't come easily. Many countries in the world resist the cost of climate change mitigation. I'm not here to give my personal opinion, but it's something which happens. I mean, this is something which can be understood. Why should we pay for something which? Why should we pay, for instance, energy at higher cost because of climate change mitigation? This does not come as an obvious. It doesn't come with an obvious answer. Of course, we're not talking about policy issues here, but I'm just saying that the cost of climate change is high. The cost of mitigation also comes at a very high price. Uh, there are several studies. I'm not, some of them again, this is, I'm very pleased to give this talk, and I'm very pleased that I can reach, let's say, a multi-region audience. But of course, it would be nicer to be in presence. People may argue that, okay, for instance, these data here comes from the International Energy Agency. So people could say, okay, I dispute these numbers. And fair enough. I mean, they can be disputed, but the overall uh, values are kind of the same wherever you look at. There is the question of a new concept which is coming up, of course, is energy transition. And energy transition goes with the mitigation of or the reducing of greenhouse gases. These are more data and information about how to reduce greenhouse gases. And this will transition later on in my presentation on the technology. There is, let's say, one major change in the energy transition is to move away from fossil fuels to renewables, and this is to make it simple. And by the way, this graphic here is a bit misleading because nuclear is also a fossil fuel. There's still uranium which is used, but it's less CO2 emitting fossil fuel than, let's say, coal and oil and gas. Sorry. Uh, so renewables is something which has been growing tremendously, and I'll come back on this later. And the second graph on the left-hand side, the blue one on grid investments, is something to be considered. It does not come obviously in the minds of many policymakers. Uh, is becoming more and more uh, clear to policymakers now. Let's say that 10 years back, many people in a very simplistic vision thought that increasing renewables, in particular the famous solar and wind energy, would make the trick. But but at the outset, people, experts in particular from the power system and power grid world, knew that this needed grid investment. For one, the obvious grid investment is that you need to connect the renewables to the main grid, but it's more than that. And I'll try and remember explain why it's more than just a connection. And the amount of dollars uh, on grid investment is very high. Uh, I will move on, and this is, I find, a very illuminating uh, slide on the technology and the technology path or avenues towards reducing greenhouse gas emission. So there are differences there. So you have this pie chart. Let's say a fourth comes through renewables. So by renewables, the most renowned one, or not renowned, but I mean the fastest growing, which we solar in solar photovoltaics in particular, and wind. Then there's energy efficiency. This is something which is not under considered, but I mean, people know that lots of gains could be achieved through better energy efficiency. It is something which is taking up very fast. For instance, the home heating, home cooling can be improved, industry cooling, and so on can be also improved. And this energy efficiency is one way of getting things better. Then the important new, not the new one, but something which is taking up pretty fast now is the yellow part of this chart, which is electrification. So what is commonly understood as electrification is the fact of using electricity for processes that were before uh, performed by fossil fuels. One very clear example of this is electric vehicles. So instead of having gas or diesel or petrol in your car or truck, you would use electricity through batteries. So this is one example of electrification which comes to mind immediately. Is being developed very fast, depends on countries of the world, but this is one obvious way of electrification. They are more sophisticated, not more sophisticated. Electric vehicles is pretty sophisticated, and for the people who have seen this going up, I mean, the energy transition over the past years or decades, even, like I would say, fortunately or unfortunately, is my case because I've been around for quite a while. Uh, the rate at which electric vehicles are coming up is pretty impressive. But there are other ways of electrifying industry. Uh, the I'm not sure. I don't think I have the slide specific on that. But cement and steel. This is a very famous kind of example. If steel or cement were a country, they would be emitting more greenhouse gases like than, let's say, Germany. They would be the third largest greenhouse gas emitter in the world after the US and China, or China and the US. So it's pretty massive. Now, electrifying the manufacturing of steel is not a piece of cake because you've got to go to extremely high temperatures, and going through extremely high temperatures, nothing better than coal or gas-fired plants. But still, it's something which is taking place. The major industries in steel, for instance, are working on that. You see also hydrogen uh, as a possible way of improving or reducing the emission of CO2. It's a more difficult hydrogen. I want to stop here just 1 minute because even though I may have some time to discuss this further, this does not come as it's not something which is as uh, easy to understand and prove than the other issues. because you got to transfer energy to hydrogen. For instance, if you want to have airplanes moved out of hydrogen, you still have to produce this hydrogen. So if you produce it with electricity, then you come back to the same question. Uh, I will come back on other issues there, but no, yes, no, sorry. There is this carbon capture storage. This again is something which is pretty advanced in some regions of the world with large, more than pilots. It's being done. The objectives to, of course, as the name says, to capture CO2, and you could put this at the downstream of industrial process. Instead of releasing CO2, you would just store it in a cave or of some sorts. And there is the development of battery storage. I will come back on that. Um, Energy transition, as mentioned, was is coming with more renewable energy sources. And in renewable energy sources that we mentioned, so photovoltaics and wind, intermittency is a key term. Of course, you don't have sun at nighttime, but sometimes as the weather becomes cloudy or even hazy, the peak generation drops dramatically, and the wind likewise. I'm based in Europe. I didn't say that, but it is true for Europe and other places too. The peak of demand of electricity in Europe tends to be in the winter, as for instance in Asia and America tend to be in the summer because of air conditioning. But here is because of the cold. And sometimes when it gets very cold over Europe for weather reasons, the wind drops. So it gets cold. There's a need for more energy, and the energy generated through wind stops. And if it's in the winter, there's less sunshine. So this means that intermittent renewables lead to challenges that need to be met. Uh, and this again means technology. Uh, I'm not going to go into the details. I can answer questions if needed, but there are some technicalities on that. The traditional way of operating a power grid or power system, by traditional, I mean before the renewables came with such a strong share, would be to have rotating machines and these through turbines that would be run through fossil fuels or nuclear or water, hydraulics, which delivered what is called inertia. Inertia is a way of having a constant frequency like 60 hertz or 50 hertz, which keeps the electricity grid stable. If you have all these photovoltaics and renewable and wind, you need special devices, which are called inverters. And so technology is needed to get all this running smoothly. And many experts of IEEE have been involved in this design of this new technology. There is a need for more storage. And storage is a way of there's an obvious explanation on that. You have sunshine during daytime, then you can if you have more, you generate more electricity than needed, you store it, and then you retrieve this energy later on. Pump storage is another technology. So this is something which is where technology makes a difference. I like sharing some data about the way the costs have been dropping. And this is solar photovoltaics. For each of my slides, there is a source you can go to. I don't see it right now because of the way my computer computer screen is organized. But again, you can dispute this particular uh, chart here, but most are going in the same direction. There's a common saying that for photovoltaics, the the optimistic people were actually very pessimistic. So the price of generating photovoltaics have gone down much faster than anyone would expect. So this led to this revolution in photovoltaics that we're experiencing right now. Some forecasts mention that by the 2050, maybe solar photovoltaics would be the first primary global energy sources. So it's quite amazing. And of course, some very sunny countries and regions of the world use it a lot, but not only. In Europe, Northern Europe use a lot as well. So this is the example of why the technology makes a difference, and technology behind PV, photovoltaics, for instance, goes in many ways, and you would find experts within IEEE, which are very strong on this. This is the example of uh, the I don't see it in the title, but it's the price of storage and battery electricity storage. I hope it's written somewhere there. But again, it's not as dramatic, but it's going down. So the price of batteries, and in batteries that experts tend to categorize two types of batteries: the ones which are moving batteries, like the one you have in electric vehicles, and the stationary batteries, the one that you would find for those of you, for instance, who are based in California, which is the world's largest battery energy electricity storage of the world. I mean, that's where, sorry, putting the sentence correctly. In California, you would find the highest number of batteries in the world today. But this will definitely increase a lot. I'm just going to stop you just a second for sharing a thought. It's interesting to see how some developments which start in a particular region of the world, then suddenly it's not that it moved away from that region, but other regions took over and went very quick on this technology. If I take the example, which I know reasonably well by my background, which is offshore energy generation, so windmills in the sea, the UK was number one in the world, and now China is. You could say that China is a giant in terms of a country, but still, it's interesting to see how this technology moves around. And I'm sure that in 5 years' time, this will still be going down very quickly. So on technology, in a way of summing up my slide, my previous slide. So there's the question of change of the energy mix, but there is the what I put here at the top, that I thought is the second line, first bullet, sorry, is no transmission, no transition. This is not a kind of phrase that I've devised, but it's something which is pretty much well received issue now amongst the experts. The transmission grid needs to be uh, expanded. So investment in a transmission grid is necessary not only to connect the generation, but also to guarantee reliability. I mean, reliability is something which is pure technology, but also pure, uh, it's fundamental for society. Without power system reliability, you don't have constant frequency, you don't have constant voltage, you may not have constant power delivery. So this is fundamental. I've discussed about transportation, electric, so energy efficiency. I've alluded to electrification. I've mentioned cement and steel transport as a or transportation as one example. Buildings is also something very important. Buildings partly because it's made out of steel and cement, but also the usage of electricity in buildings. And here on the title of my slide, you may find a slide development. We have technology, climate change, and sustainable development. Some of the work that is being done here addresses the climate change, but also sustainable development. And there are things which are combined to climate change. So that's why we have the agriculture and food for all issue. I call it food for all. And it's not only a question of, let's say, uh, places in the world where there's famine and hunger, even though this is pretty dire, and we should look into it, but also the fact that the usage of water for agriculture, or the use of I mean agriculture and energy, if I may say so, need to work, if not hand to hand, to avoid competing with one another. I'm going to just give you one example amongst many others. About 10 years ago, I think it was, in Mexico, there were some, I don't recall the exact term of this, but there was a very strong movement of having uh, crops used to produce ethanol and energy for cars, but this was at the cost of maize or cereal growth for food. So this led to some the word riot is maybe too strong, but certainly some demonstrations, mass demonstration against what was going on. So this is an example of when agriculture, food, and energy have to go together. The question of water also is something which is it's an obvious question. Okay, contrary, by the way, to some misrepresentation, the quantity of water on Earth is stable. Nothing, I mean, there's no generation of water. We have the same amount of water, whatever we do. But what does change is the amount of drinkable and water and fresh water, and this also leads to some competition. For instance, in Europe, where I'm based, there was a question a couple of years ago, 3 years ago, when there was a very hot summer, and the temperature of the rivers and even of the sea, but the rivers went up. So the nuclear plants had to reduce their generation because during the process of cooling their reactors, they take upstream some water from the river, and then it goes up. I mean, then it goes downstream, and the temperature goes up, and this led to some issues. So uh, all this goes together. The last part of this slide is something which I will be illustrating in my next slide, but just to say that uh, there is a question also of having, okay, tech, this is slightly going beyond technology, but it's saying that there is a global discussion about countries throughout the world should reduce their CO2 emission, for instance, or their greenhouse gas emission. I've been involved in several energy conferences over the years, and I know that there are some pushbacks on this because some countries say, well, many things are said. For one, they say, okay, the main industrial countries are in large part responsible for what's going on, and now you impose thing on us, and this is unfair. This is not my saying; it is something which is said. Also, some mis misrepresentation are sometimes done. And I've heard people who have kind of ministry level from Africa saying, don't ask us to leapfrog. This is not always doable. You cannot go necessarily, let's say, from a country where you use dirty coal, to, I mean, kind of the real bad coal, and towards, clean, nice PV and wind and whatnot. It's not always doable. And you've got to have this, bear this in mind. And my next slide is just something which is not about technology, but it's just to share. And this is I've got the sources at the bottom, which comes from a European Commission, but you can find this on Wikipedia. So it's a screenshot, so you may not read this very well. But the interesting thing is the second column or the third. I mean, the one which says how many ton per CO2 per capita, depending on the countries. So you have about 6 tons in Europe, about 14 tons in US, about 20 in United Arab Emirates, 10 in China. And then you go down to countries that are very strong economies like Brazil and India. You go down to 2 tons of CO2. And if you go to Nigeria, which is, I believe now, Africa's largest economy by GDP, it's zero point 0.6 ton per CO2, and likewise for Ivory Coast, to give another example for a country which I work with. So it's a sign that there is a big discrepancy, and putting the effort, a similar effort to all, may not necessarily be well accepted. It also means, and this is something which is, and I'm back on technology here. I don't have the slide here to show this, but I would encourage you to look it up on your favorite browser. The amount of installed PV or even solar. Solar it can comes in photovoltaics, but also other kinds of energy generation, like heat, boiling water, and using it in turbines. If you look at the amount of solar installed in Africa, it's zilch. I mean, this is something which is completely counterintuitive. Like 15 years ago, or 12 years ago, maybe, the country with the most photovoltaics in the world, not per capita, but in, most photovoltaics, was Germany. So maybe some people here are attending from Germany, and some people may know Germany. Germany is a great country, but it's certainly not the most sunny of all countries. Still, they had a very strong solar PV basis. Africa, which has a lot of sunshine, has virtually no solar installed. So it's something which has got to be thought of. This means that technology has. I mean, I'm not here to give policies. I'm just here to share knowledge and thoughts. And if you would have to think of where you would put some solar, you would naturally think, I'd rather put them in Africa than in Germany, for instance. But that's not the way it goes. Okay, so I'm now addressing the third part of my presentation. So after having reminding the importance of climate change, then the importance of technology, now is focusing more on IEEE. So IEEE has many reasons to well to be part of this global effort on climate change. This has been going on for quite a while, many years now. Many initiatives at different levels, and I will come back in my next slide. But the overall view that I want to share with you, that IEEE, 500,000 members, has a very strong expertise on climate change related issues or on sustainable development related issues. It just to make things clear, I'm not saying that all members do. Some members are on very specific topics, but out of this half, or maybe I don't know exactly the membership IEEE has now, but about 450,000. So I would round it to 500,000 in about 150 countries. So it's massive. And we have a very strong experience and knowledge on climate change and sustainable development issues. So it is important to me. Many things are important, and I say to me because this is a part of an initiative which I started, but also I shared with many members at the board of directors when I was a member of that board, member for 3 years, or with other leadership uh, teams within IEEE, is that many things could be done to share more amongst experts within IEEE. Also, outside of the IEEE. And this is my second bullet here. IEEE has all the possibility to be a trusted source of expertise. Now, I'm going to stop here for a minute just to not to explain, because of course you all know what it means, but just to to maybe express the force of this, and probably also the limits. For some topics on climate change aspect or sustainable development, the jury is still out. I'm just going to give you one example. Uh, should we use more hydrogen? If you interviewed many experts within IEEE, you'd have different answers. So it doesn't mean that it's right or wrong. It's not a mathematical demonstration. It's not a physics law. It's more kind of there are pros and cons. But IEEE has experts and with unheated lines of reasoning, which still would enable to give a trust source of expertise. Like if I take again my example of hydrogen, say, okay, advantage of using more hydrogen is this, this, and that. uh, we also remind you all that hydrogen is not an energy source, but an energy vector. So you to have hydrogen, you've got to generate hydrogen. There are many ways of doing this. Again, as experts, we can say, okay, people talk about colors of hydrogen. I mean, hydrogen, for those who know, of course, has no color, but it comes in the color blue, in the color green, in the color gray, in the color brown. People come up with many We have lots of innovative people around the world. So, but we can explain this. And for some of the topics, then there's no discussion. The jurists come back and say, okay, this is the way it should be done. Like for instance, more intermittency on the power grid. Then you need to produce inertia. You need inertia to guarantee a 50 hertz or 60 hertz grid. So we have different kinds of expertise, but we're certainly a trusted source of expertise. And I like to underline this because this is one of the strengths of IEEE. So IEEE has a role because it's got a strong expertise uh, on these issues. It can be a trusted source of expertise, and also, this is something which we had discussed 4 or 5 years ago. Uh, Working on climate change is also, as a byproduct, a way to attract talents, members, and industry. I come from industry, so I mention industry here because I find it very important. Uh, this is not only my thought. You may find many young or non-young, not young people who are not IEEE members very interested or wanting to work on climate change related issues, climate change or sustainable development. Now, if they hear about IEEE, it's important they know, okay, oh wow, is IEEE doing anything on that? Yes. So having an IEEE climate change clear, let's say, entry point is part of what is expected out of this. So attracting talents, members, and also industry. Industry for many reasons. We have industries which are very strong on this climate change, which pretty much are involved in this already. But some industries which may be less. And by the way, this is maybe the only moment when I'll discuss that because I don't have a specific slide on this. When we have discussed about IEEE and climate change, a lot. Immediately, energy comes to mind, but information technology is also a very strong point. And this was already a strong point when we first started to put up some joint board of directors level committees a few years back, or technical activities board committees a few years back. Already was very strong, and now you see that it's becoming stronger and stronger. And just to mention, I don't want to be US centric, but I just want to mention this nevertheless. When you see that Microsoft is trying to build a partnership with a, I think it's Constellation, I'm not sure the name of the company, but to revive the nuclear plant of 3 Mile Island because they need energy plants, sorry, energy sources which is not, or little greenhouse gas emitter to run either the data centers or things like this. It shows the importance of that. So IT, so information technology, data centers, artificial intelligence, AI, all these of course, are related to energy, and energy is related to climate change. So IT is a great, not a great, I mean, it's a very important, let's say, player, and it will become more and more important player on climate change issues. And of course, I'm not going to mention all the companies which are this kind of objective. And the last bullet here is that we have when we say, okay, we can develop the IEEE work is increase the global visibility of IEEE. The global visibility of IEEE, full stop, not necessarily on climate change, but being present on climate change puts IEEE more on the radar screen. Again, this can be debated, it can be discussed, but this is my strong view, and I know that others share this with me. Because again, climate change and sustainable development are issues which are debated at a global level, and being a player on this put us on the radar screen. I have an anecdote that was not an anecdote, sorry, a story that was shared by IEEE 2020. Three President Saifur Rahman. At the end of 23, he went to the UK and he met Princess Anne, and she asked, "Okay, so what does IEEE do?" And Saifur Rahman mentioned that IEEE is involved in climate change and climate change mitigation. And immediately she understood what he meant. I mean, Her Royal Highness Princess Anne. So, I mean, it just shows that it makes things not easier, but it's a way of showing what we do. So I think it's important. And this is just to continue on this visibility aspect, uh, the way things have taken place at IEEE levels, many initiatives were started in different. So for those who are used to so it's capital O, capital U. So organizational units. So many major organizational units have been active on climate change over the years. So Education Activities Board, membership, geographical activity, publication services, and product boards, standards association, technical activities board, and IEEE USA. So this took place. Then other initiatives were launched. I'm just underlying one which I was responsible of because I was at the time chair of Technical Activities Board tab in 2022. I launched this climate change program, and this again led to other initiatives. There is a Technical Activities Board, a Future Directions Committee, FDC, which launched a SUSTEC initiative in 23. And I saw that there will be a presentation on SUSTEC initiative, I think sometime this week by Michael Lukin. We've participated to many global conferences, various global conferences, but including the ones which are held yearly by the United Nations. There are several types, but on climate change, there are COPs, which means Conference of the Parties. So since COP 26, which was in Glasgow, and I participated to that remotely at that time. But since then, IEEE has been present to all of them, and so I think it's next week sometime that the COP will take place in uh, Baku, Uzbekistan. Uh, and the last bullet is many technical activity societies are very active. So a lot is taking place, and sharing knowledge is part of what should be done. The next slide, I'm going to speed up. This is an interesting poll which was made in the USA by the Power and Energy Society. This poll says, okay, so engineers who develop, according to nationwide means the US, the public trusts engineers to develop climate change solutions more than any other profession. So people are listening to this talk should feel the pride, but also the responsibility of the expectation from our fellow citizens. So this is a poll, so it's not, but it's still very interesting to see the trust that exists. Excuse me. And at the same time, there are some discussions I should also mention that technology is not something which you're going to pour technology on the planets and everything will be solved. I think this is much more complicated than that, but still it's interesting to note what's going on. Okay, this is not my last slide because then I've got a series of them, but this is the last where I'm going to stop before the very last one. This is a very busy slide to show that there are many initiatives which are taking place presently at IEEE. This has just, it's not a snapshot because it's probably a few months old already, but it's continuing, moving, evolving. It's in a way a lot technical activities centered, but not only. This is probably because I'm also a technical activities person more than let's say other major OUs, but things are taking place throughout. And this example of this online forum, by the way, is a great example of what's going on. I mean, it's just and I want to commend the organizers for organizing this meeting. So plenty of things taking place. I'm going to just zoom very quickly. Okay, this is the name of the society. This is a reminder of the different uh, activities which are taking place. stopping here for 1 second, if you go on your favorite you can look up climate change, climate dash change at IEEE, and this is a moving screen. So you have the latest of the initiatives which are taking place. So it's pretty active. This is another one. All this you can find on this climate change one. Uh, there is so I'm not so again you have plenty of them. Stop here for a second. IEEE Power and Energy Society will launch a new magazine. The first issue is in May 2025, so we've got time. But it's interesting that to see that it's being announced, prepared, has been approved by by the board of directors by IEEE PS. This is the Planet Positive. This is Suspect. You'll have more on that. This is an initiative which is called GPST. I'm not going to cover all this. And these are links, probably some more links now. Probably even this is not completely up to date. Uh, it's a global corporation. And I'll move now to my okay. The IEEE Spectrum has published a lot on climate change. And I want now to take a second. This is my final slide potential next steps. So, to one, IEEE has recognized climate change as a strategic topic for many reasons that I've covered very briefly. Uh, there are challenges for collaborative work. Uh, this is a possibility for different organizational units, TAP societies to work together. Many people sometimes say that IEEE has uh, sometimes works too much on in silos. Nobody wants to work in silos, but it's a matter of fact. I mean, so breaking silos through this issue is great. It's a global and a geopolitical issue. We can have on this topic position papers. We can increase the visibility. We can reinforce the role of IEEE as a trusted source. Uh, and of course we can attract key players here on the slide before last, having something on from for students, young professionals, industry from all regions of the world. And by the way, I noticed that this particular forum has the support of I think five of the 8 regions. And the last bullet is just it's not a teaser, but it is saying that for 2025 certainly things will continue. There will be this is on the question of work of for for climate change in 2025 and beyond is in at the agenda of at very least the board of directors and the technical activities boards and other issues. And this will be discussion will take place in November at the IEEE series. And with this, I want to conclude my talk. Thank you very much, and over to you, Charlie.
Thank you, Bruno. I really enjoyed your talk. It covered a lot of great aspects. I don't see a lot of questions in the chat room yet. But one question I have for you is, which technology do you personally want to focus on for what I'll call zero emission energy?
Thank you. It's a very good point. I've covered the fact that many topics have been developing very fast. The one that is not lagging behind, but the one which is crucial is storage. Storage, be it batteries for stationary batteries like the ones you have now in California, batteries for electric vehicles. So storage in all different forms. If I had to pick one, it's storage.
Okay. Um, that reminds me that if you ever visit Palm Springs, you can take a windmill tour on one hand, and you can actually see a battery storage facility north of Palm Springs.
Thank you.
So I'm going over the list looking for questions. Okay, is there any research of CCS for open to everyone to study the process of CCS and implement it in real life with some changes? I
Yes,
think,
carbon capture storage
yeah.
has had more than research. It has pilots. There are some countries which are very in advance, like for instance the US. I don't have the references for the work now. Uh, Probably it's available even through IEEE Expro, but I'm not sure. But certainly, carbon capture has a series of challenges combined with it. For one, this is something which I just want to say. I'm in favor of. I mean, I'm not the one to judge. Carbon capture is a great idea. People should remember that if there's a leak and the carbon CO2 goes out, it's heavy gas, so it stay there. So it may have some kind of problems of for the people around the plant. So it's a tricky installation, but certainly a very good idea of combining carbon capture with industry. Some industries, yes.
Yeah. One of our attendees has a power outage, so he's listening with his laptop, and he'll, when the battery wears out, he'll be done. Um, a lot of places have backup energy generators, and we're starting to see battery backups in a lot of places. Um, However, somebody points out carrying a big battery around with you all the time is kind of tedious. Um, there's another question here about how about initiatives related to climate restoration, for instance, CO2 and methane removal from the atmosphere?
Yes, this is something which has been discussed by some experts with a lot of discussion, pros and cons, because these are technologies which move around with clouds and lots of different ideas which come up. Uh, it's not a global technology which is approved and accepted by all. It does not mean that it shouldn't move forward, but it means that there's some opponents to that. But again, over the past decades, I've seen opponents to nuclear energy, which are now favorable to nuclear energy. So things move. But yes, this is also. I wouldn't use the term promising, but this is a technology which you hear about. I know little about it, but I hear many people having concerns. I don't know well enough for being a strong advocate, put it this way.
Yeah. I think this will be sort of the last question slash comment. Um, with challenges of mining or sourcing materials for energy generation, how do you see the balance with climate change? I think what's being addressed is I want people to think of California was founded because of a gold rush. Thousands of people came to California trying to get gold, and hundreds died while trying to get their gold. And once they got to California, they realized there are better ways to make a living. Do you see issues with lithium mining versus coal mining?
Yeah, very good point. And by the way, in California, the people who got the money, I understand, were the shovel sellers more than the gold diggers. Uh, I've seen things happen over the past years. And if you take just the case of cobalt and manganese, and the lithium is, of course, is the smoking gun, if I may say so, but even others like cobalt and manganese, we are over the past 5 years, we've seen new technologies with different amount of cobalt being used, which change the let's say the business model altogether. For those who are familiar with this, cobalt basically there are two kinds of cobalt. I'm not going to get into the details, but it basically comes from the Democratic Republic of Congo. Some of it is dug mined reasonably easily, the other is not. Some people mention children being used to do the mining. So then people say, hey, we're not going to do the energy transition because of lack of cobalt. And then suddenly cobalt arrived. And as for the lithium, yes, it's true that's a couple of years, no, 10 years ago, people say lithium is just maybe in Chile and some countries, only China. But now more and more is coming up. I'll make a poor comparison. But for those who remember when we discussed the peak oil, saying that's when oil will end, I think the peak oil was scheduled for, or I mean, forecast for the 1970s. Now we're in the 2020s, and we still don't see the peak oil. So the more these metals and other materials will be needed, the more, well, people will be ready to spend more money to dig it, just like the North Sea North Sea gas in the 1970s. So I don't think it's a concern. I certainly don't think that we should stop because of that. But yes, there may be, for one, a lack of material happen. But then the technologists, and many of them are connected here today, may think of better ways, of other ways of developing these technologies.
Okay, that's a very good point. I want to thank you, Bruno. Thank you for an excellent talk. I think now we'll sort of do a transition to the next talk. So again, this is where online is not satisfying. You can't really hear people clapping in the background. But thank you, Bruno.
Thank you. Thank you all very much. Have a good, productive meeting. Bye bye.
Bye.